Yo! What's up, everybody? This is the video for 10.1 comparing dot plots. So it's going to be really simple. Not a lot of math, a little bit of math for mean and median and range, but not a lot of calculations when I say not a lot of math. It's going to be mostly looking at some data sets and just talking about what we see and what they mean. So, vote key terms. Get these down. Dot plot, mean, median, range. You should have already seen, and I know that you've already seen mean, median, and range. So those are something that should look familiar. Dot plot should also look familiar. If it doesn't, that might be something that's new. To get those down, we'll talk about what they mean throughout the video. So first, a dot plot is this right here. It is the way to display a set of data. Okay. So people once used their body parts for measurements. So what we did is we took the length from the nose to the thumb of a bunch of different people, and we measured them. Okay. In the 12th century, King Henry of England stated that a yard was the distance from his nose to his outreached arm's thumb. So that's how they figured out how far a yard was. The dot plot shows different lengths in inches of yards for students in the 7th grade class. So that's the distance in inches from a nose to your thumb. So we displayed that class, okay? And what we did is each one of these dots represents a student. So we're just going to describe what we see here. Describe the shape of the dot plot. Are the dots evenly distributed, or are they grouped on one side? So we're just looking to say, are they kind of spread out evenly? Is there just a bunch on the right, a bunch on the left, or a bunch in the middle? And then we just write that down, what we see here. So the shape, I would say, is evenly distributed. There's not a big clump. It's not like most people are over here between 31 and 35. There's just a few over here at 28 and 29. It's pretty evenly distributed. Okay, we have this one, the mode or the most right here is at 31, but the rest is just 2 or 1, and it's all pretty much spread out between 28 and 35. Then we want to describe the center of the dot plot. What single dot would best represent the data? So the centers, we're looking at where in the middle, we're looking for the middle value, and this can be just something where it could be visually where's the center, and it looks like at 31 here. I have the most people at 31. Maybe 31 and a half. Okay, but that's where the most people are at, and that is a middle value in this data. So the center is at 31. That has the most values. And describe the spread of the dot plot. Are there any outliers? Spread means how far apart does it go? What's the range of the dot plot? So it's from your minimum to your maximum. So the spread's from 28 to 35. And I would say that there are no outliers. 35 isn't very far from 34 and the rest of the data. 28, I mean, because most of the data is between 30 and 34 or 35, and then there's this 28 out here, but it's still consistent with the data. So the spread is from 28 to 35. And I would say no outliers. Some might try to argue with me and say that 28 is an outlier, but 29's got 2 data points right next to it. It's not that far off the data, so I would not call that an outlier. Okay, so that's it. You're just describing what you see. Is it evenly distributed? Is it not evenly distributed? Where's the center? And then what's the range? How far spread out is this data? Sometimes you also might have to calculate the mean, median, and range of the data. So first, let's go with median and range first, because mean's the one that takes the most amount of time. So the median means middle value. So the way I find the middle value is I just cross off my data points from one side to the next, one side to the next, one side to the next, until I get to the middle. And I'm left at 31 and a half. So the median is 31.5. I'll actually write down median. Your range is just take the largest value and subtract the smallest value. 35 minus 28, 7. And then the mean is the average of the data. This is where it's nice to have a calculator, because what you need to do is you need to take all of these values, add them all up, and then divide by how many values that you have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 values. And what I'm dividing by 21 is all of these numbers added together. So this is a 28. So what I'm going to do is I'll take my handy dandy calculator here. I'll take 28 and I'm going to add it with the rest. I have two 29s. So I'm going to add it with 29. I'm going to add it with another 29. I have 130. I have two 30 and a halves. Cool part is a lot of calculators will show you. You see this one? It shows me everything I've added in. I have three 31s. 31s times 3 is just 93. So I'm going to add 93 here. Two 31 and a half. I'm just going to add 62. I'm doing some quick math. I'm sorry, 63. I'm going to do some quick math just so I don't have to, you don't have to watch me plug a bunch of stuff into a calculator. Two 32s is 64. Two 32 and a half is 65. Two 33s is 66. 33.5. And then two 34s is 68. And the 135. So I got 664.5. And I have to divide that by 21 because there's 21 data sets, and this is going to give me my average. Where's division? Oh, there it is. Which is 31.64. We'll round to the nearest hundredth. So the average was 31.64, which is pretty close to 31.5, which was our median. We said our center was around 31, so all pretty close. And that's it. Now, for this one, you might compare two different dot plots, and yeah, you might just compare two different ones and see what it shows. So if I were to compare the shape of softball players' heights and basketball player heights, so here's a data set of softball players' heights, here's a data set of basketball players' heights. If I were to compare those two, right away the first thing I notice about shape is the basketball players are taller. They're more, have a spread that's more to the right, skewed to the right hand side. So basketball players are weighted to the right, or you could put skewed to the right. Meaning they are taller. Softball players are evenly distributed. I would say this is pretty evenly distributed. We have our one big, a lot of them are 5'4", but other than that, it's pretty evenly distributed. So I would put softball evenly distributed. I'm just going to put softball evenly so you guys don't have to see me write a bunch. But I would put evenly distributed. Center of the data. Looks like basketball at 5'8". Softball at 5'4". And then the spread, this spread, softball, from 4'11" to 5'6", basketball the spread is from 5'2" all the way to 6 feet. Okay, that's it. We're just comparing the two, showing that this is all of this points out that basketball players are just tall. That's it. There's nothing else to this. Okay, so it's just looking at it, comparing, and then making some inferences and some generalizations about the data that we see. Okay. Things to remember: mean, add all values, then divide by the number of values. So that's probably the most common mistake. Okay, guys, thanks for watching. If you have any questions, let me know. Credias is out.